Okay, let us start our class. So due to your request, I am just doing the camera off.
Yes, sir.
Okay. So let us just review what we did yesterday. So you see, we have discussed about definition of probability two ways: relative frequency and axiomatic definition. Two definitions. The idea is same. Idea is same. We have discussed, and then we have defined that if it is mutually exclusive, then this condition satisfy P of A union
Sir,
B
can you
equal.
explain the total probability theorem in brief once?
Sorry.
Sir, have you shared your screen?
Oh, sorry. Thank you. Sorry. I forgot to it. Yeah, I have not shared my screen. Thank you for reminding. Yeah, I hope it works.
Yes, sir. Now it's okay.
Okay, thank you. So you see, we have discussed about the definition of probability. Two ways the definition, relative frequency and axiomatic definition. And we have done the, if it is mutually exclusive, then this condition satisfy. Probability of A union B equal probability of A plus probability of B. So we can take here one little small example. So for example, suppose we are throwing a die. That means a die has 6 outputs, either 1 or 2 or 3 or 4 or 5 or 6. This out of the 6, any one will come. But if the event is suppose 1 and 2, 1 or 2, then the probably if event 1 is we consider A and event B we consider 2, then A union B actually your if your event will come if A or B is going to top. So then it is actually the probability of A. It is probability of A is 1 by 6 and probability of B is 1 by 6. And if you add these two, 1 by 6 plus 1 by 6, it is 2 by 3, 2 by 6, and basically 1 by 3. And A union B, that means what is the probability of A or B? That means 1 or 2 will go out on top. So your event is 2 type and total space is 6. So 2 by 6. Like this actually. Union means we are just together this. These or that anyone is happening, then we are taking this union. And we have discussed this axiomatic definition. This finite case and infinite case for sample space. And here, if the all are equal probability, that means for the throwing a die, it is we are considering throwing a fair die. We are considering it is equally likely probability. So that's why it is. So for probability of 1 or probability of 2 or probability of 3, all are same. That means it is equal to 1 by 6. So this and we have defined the conditional probability. That probability of A such that B is given, then we define this probability of A intersection B over probability of B, so that probability of B should be greater than 0. And from that we have constructed a base rule. Probability of A such that given B is equal to probability of B such that given A into probability of A over probability of B. So the benefit of this theory is that if suppose it is difficult to find the probability of A given B, we just take opposite way. Sometimes the opposite, that means probability of B given A, it's sometimes easier. So that's the time we use base rule, and generalization of this is actually base theorem. And if these events are n events which are mutually exclusive and exhaustive, then the base theorem we have constructed, and finally the base theorem is this one. Probability of AI given B is equal to probability of B given AI into probability of AI over summation of all possible cases. That means I equal to 1 to n
Sir, can
probability
you
of
explain the base theorem in brief?
base theorem
I
in
could not brief, sir. I cannot get that. The base theorem.
as a base theorem. No, base theorem We have just discussed yesterday. Okay. So here what we did, suppose the events are finite. That means sample space, you can think it is finite, A1, A2, An. The condition is this should be mutually exclusive and exhaustive. And these two basically means mutually exclusive means their intersection is always phi. Any two distinct these events are many two distinct samples are intersection phi. And the union of these samples should be the whole sample. Then with some calculation, we did this one. We can't repeat again, you see clearly. And I have given the PDF also, it is properly written. You see first, if you feel again difficult, I can discuss later on. But I can't repeat these things because, and I hope you will clear with some examples. I am going to discuss today that. And we did some calculation here using Bayes rule and some conditional probability definition. We have finally reached this one. And that was the yesterday's class. Now today we are going to discuss about some examples. We try to do. So be sit with your pen and pencil, then copy and pen. I'm giving some problems. You try to solve yourself. Then I'll discuss. So let us try to do this one. Question number 1. I hope you are able to see. You read it. Answer is given somehow, but you need to understand why this answer is correct.
Because sir, each question has two probability of gain true or false. Then for 10 question it would be 2 to the power 10.
And sir, all events are independent to each other, so that is why they will be multiplied.
Yes.
Here we can even use NCR P to the power R Qn minus R. But here,
There is
sir, the R will be N.
I get all the
So
answers correct. That's why 1 by n.
Sir, for each
Yes, sir.
question
All
you get
the
correct, the
all the
probability is
answers
1 by
will
2.
be
So for
correct
every
for
question,
one
1 by
time.
2
Okay.
power 10.
So if you use a pure guessing, that means suppose whatever you have same one, you just suppose 10 question you have set it. It is question is true and false. That is two possibilities. So now the question is suppose anyone giving randomly, anyone, this is true, this is false, this is true, without reading the question, they are giving answer. Good. Then what is the probability that you will get them all right? So
One time.
so it is better. So what is the that means if we do like this, then what is the possible cases of answers?
So there is only one possible case of the answer of getting all right.
Yeah, one possible, and that means whatever your event is actually one possible.
Yes,
That
sir.
is all are right.
Yes, sir, one possible.
But what is
But
the
sir, each
space?
question has
What
two
is the
possibility. For 10 question it will be 2 to the
So,
power.
sir, yeah.
yeah?
1 by 2.
That means you follow the first position. The possibilities is either true or false. That means two possibilities. And similarly, second one is either true or false. So together these first two positions, how many possibilities? It is 2 into 2,
Four
Sir.
possibilities.
4 possibilities. And if we increase the length, again, third position, it is again true or false. So what is the total possibilities? It is again multiplied by 2.
Yes, sir. Total
Eight.
sample of cases will be
So
2 to the
like
power
this
10.
way, it is 2 into 2 into 2 dotted 10 times. So
10
basically
times
that is,
multiplied.
yeah,
2 to the power.
that is 10 times multiplication. So it is 2 to the power 10. And out of
sir,
this 2 to the power 10, it is only one is the event. That is, if one case is all are correct, that is one case. So it is the probability is 1 by 2 to the power 10. I hope it is fine.
Sir.
Is it
1
fine?
by 512.
sir,
100, 1 by
Answer is
512, sir. 512.
2 to the power 10 equal to 512.
no, sir. Twice. Twice
no,
of
sir,
that.
No, sir. 512 is 2.9. That is 2.
Sir,
Correct or not, sir?
1 by 2 to the power 10 equal to 102 to the power 4. You may use
1024.
Yes, sir. That is correct, sir.
Oh,
That is
yes, sir.
correct. Yeah. So let us proceed for second one. I hope first one you all able to get it. Proceed for second one. You read it second one and try to remember.
Sir, I guess denominator should be 2 to the power 16.
Sir,
Mm-hmm.
To the power 10,
if
sir,
the
I think
question,
total way to answer question is 2 to the power 10.
sir, if in the first question, in the place of true false, if it was given
Yes, sir.
4 option MCQ,
Yeah.
then the answer.
Answer will be 1 by 4 ki power 10.
Sir, it should be
No,
sir 10C7 plus 10C8 plus 10C9 plus 10C10 by 2 to the power 10. Second one will be.
Yes.
you are
Yes, sir.
talking.
Yes, sir.
Yes,
There will be cases.
Yes, sir. Yes.
Sir, either we can eliminate getting 3 correct, 3 incorrect.
So 10C7 into 1 upon 2 ki power 7.
Just one by one. You try to do. If you talk together, yeah. Devansh Gupta. Yeah, Devansh
Yes,
Gupta.
sir.
What do you want to say?
So 10C7 into 1 upon 2 ki power 7 plus 10C8 into 1 upon 2 ki power 8 plus 10C9 into 1 upon 2 ki power 9 plus 10C10 into 1 upon 2 ki power 10.
No. No, sir.
No.
This won't be the answer.
No, sir.
Why Devnesh Gupta? Is Devnesh Gupta correct?
No, sir.
No, sir.
No, sir.
Yeah.
Sir, he hasn't taken the
So-
failure.
had found the incorrect
So,
one
yeah.
for probability
Shubham,
of
why? What is the wrong of Devnesh? Shubham.
Sir,
Sir,
the
probability of
denominator will
incorrect
The sample space should be
The
always
probability
to
to the
power
remaining
10.
one will be false is also half. He hasn't taken that into consideration.
Yeah.
We can
so-
solve
Okay.
70.
Taken the 2 into consideration, not the false one. At least 7 out of 10. So if
Sir,
7
then we
is
can
be
total
false,
1 by
No, sir.
getting set.
any 7 can be correct.
Sir, it shows at least 7, so we can say 10C7
probability
plus
minus
10C8 plus 10C9 plus 10C10.
plus 10C9 plus
These are
10C10.
all the possibilities of getting 7 correct, 8 correct, 9 correct, and 10 correct.
Exactly. That is correct. Then,
By 2 to the power 10. That is.
yeah. So
Have to
finally,
be-
who said this one? Yes, someone said this. I can't get who said, but that is correct actually. Our event means our favorable case is 7 choose 10 choose 7 plus 10 choose 8 plus 10 choose 9 plus 10 choose 10. And all total cases is 2 to the power 10, we know. So this event by 2 to the power 10, that is the correct answer. So the final answer is 10C10 plus 10C9 plus 10C8 plus 10C7 over 2 to the power 10. In simplify, we get
176 by 2 power 8, sir.
170.
Sir,
But
sir,
I have a
11 by
power
60. Answer is there already.
11 by
answer
64.
is given here actually. Yeah, you can see right side answer
Simplify
given.
it and get 11.
So
Sir, I
this
have
is
a
the
doubt.
answer. Are you getting this number 2?
Yes, sir.
Sir, explain once
Yes,
again. Sir,
Hmm.
sir, at least getting 7
Should
are
we
correct.
explain again?
Yes, sir.
Ah, okay.
Sir.
So you see question number 2. So I read this question first again. If you use pure guessing on a 10 question true false exam, what is the probability that you get at least 7 out of 10? That means at least 7 out of 10 means you can get either 7 or 8 or 9 or 10. Anyone if you get, then fine. But if you get 6, then it is not considering the probabilities. So what is the probabilities that you are getting 10? That is actually 1 by 2 to the power 10. You are done on number 1. What is the probability that you are getting 9? So these actually 10 choose 9 over 2 to the power 10. And what is the probability that you are getting 8? This is actually 10 choose 8 over 2 to the power 10. And now what is the probability that you are getting 7? It is 10 to 7 over 2 to the power 10. So, and you follow this, these events are mutually exclusive. So if you take this union, probability of these whole cases, it is actually the summation of these cases. So the
Sir,
final answer,
it will be easy way to explain. If we say have to at least 7 questions out of 10 questions have to correct. So 7 questions can be correct, or 8 questions can be correct, or 9
Exactly.
questions also can be correct, or 10 questions also we can be correct. So
Exactly.
10 is 7, or for or we use plus sign. So we can add them up, and total number of cases is to the power 10.
Yeah,
Then the
that is
probability of
that is
176 by
correct.
2 to 10. The
So
more important part is at least.
Sir,
that
sir, I
means
have
we
a
are
doubt.
getting.
Sir, can we do the reverse elimination process, like total probability minus selecting the 3 which are going to be incorrect? Like when
Yeah. Generally, if the question coming at least, then generally we do 1 minus something. That means what is not happening.
Yes, sir.
So we do
Because
that
they are.
also.
Yes, sir.
So this is actually the final answer is 10 choose 7 plus 10 choose 8 plus 10 choose 9 plus 10 choose 10 over 2 to the power 10. This is equal to that. Okay. Okay. I hope you are getting at least. If
Yes,
those
sir.
who are not
Yes,
getting, please try yourself and discuss with your friends later on. Now go ahead for question number C.
Sir, the third one will
5
be
by
4
it's
by 29.
5C1 into 4C1 divided by 30C1 into 29C1.
Sir, 5C2
Yes,
divided
sir.
by
5 by 30
30C2.
into 4 by 29. This one
Yes,
would
sir.
be
5 by 30 into 4 by 29. So because they are
Yes,
independent
sir.
events, so we can multiply the
Sir,
probability.
Sir,
because
that
there
will
is
be
then we can do the
5C1 into
30C5 plus
4C1 by
29C
30C1 into 29C1.
29C4, sir.
Yeah, you are
30C5 plus
going
29.
somehow you are going correct way. But if so, it is a nice thing is that you are trying and you are interactive with me and with your friends. That's good actually. But if you talk together all, it is difficult to catch it to me and also your friends. So it is better. So okay, who is talking? Let me check. So who want
Sir,
to
we will
interest?
use conditional probability.
Sir,
Yeah.
me.
Harsh. Okay, Harsh, please go ahead.
Sir,
Only Harsh.
actually, sir, first there are 5 defective balls in 30 in total 30. So we will take one out of one defective, so it will be 5 by 30. Sir, now
Right.
defective balls is left 4 and total balls is 29. And so
Right.
that probability of taking defective ball will be 4 by 29. And so
Exactly.
these two probabilities are independent to each other. They do not depend on each other. So we can multiply that. These two
Exactly.
probabilities.
Very good. Very good. Is it fine? Harsh, whatever said, it is actually nicely described here.
Yes, sir.
Yes, sir.
I hope you all get. So if you calculate that one and simplify, you are getting 2 over 87. Good. Very good.
Sir, once write that on the sheet, that once write.
Yeah. Harsh, thank you again. So now let us number 4. You read it and try to.
Sir,
Sir,
for
it is same
third
as
one,
previous
sir,
one, sir.
for third one, right, sir? Like what he said, 24, 30 C1, like
2 into 25 into 5
Sir,
upon
here
36.
is
25
Yeah,
25C1 into
Harsh
5C1 by
said actually
30C2.
sir,
5
for
by
third one,
25 in sorry, not this.
5 by 30, sir, into 4 by 29.
Yes, sir. 2 into 5 by
30 into
yes, sir, that will be okay.
and
4
4 by
30.
29.
4 by 29. Yes, sir.
29.
Yes.
Because
No, sir,
Because
24 by 29.
because we
25 by
take
29, sir.
and this equal to this.
because we take the second ball without replacing that.
Yeah, we are taking without
They
replacement.
both are
That's why it is
independent
4 by
events.
29. If it is with replacement, then what is the
Then it will
probability?
be 4 by 30 second
4 by
ball.
30, sir.
second. No, sir. The 5 by
4 by
30 into 5 by
29
30.
5 by 30 into 5 by 30.
5 by 30, yes, sir.
With replacement.
Square.
But sir, the probability we are asking is only at least one is defective.
Yes, sir.
No, sir. Both
both
bulbs
bulbs are
defective.
defective.
Okay,
Sir, which
anyway,
question we are doing, fourth or third one?
Sir,
leave
fourth
this
question.
No, leave this question
Sir,
number
sir, I am
3.
not clear with this question. Sir, I have one doubt. Sir, out of 30 bulbs, first I will choose the 5 which are defective, 30C5. And out of that 5, choosing question is asked for only both should be defective. So remaining 25 bulbs, they are very good. So those probability is 0. So choosing the only 5C2.
Actually, from on the upper side that will be 5C1. From the defective 5 we are taking 1, and 30C1 means we are taking 1 bulb from 30. Then without replacing, there is 29 bulbs, and 4 bulbs are defective, so we are taking 4C1 by 29C1.
Exactly. Yes, that is the. Okay, good, very good. And now try to number 4. Try to do number 4.
Sir, yes, sir.
Yes, sir,
25 C1 into 5 C1 by 30 C2 plus 5 C2 by 30 C2.
Just 1 minute.
Yes, sir.
Question number 4. A box contains 30 diodes is known to contain 5 defective ones. Out of 30, again just previous one
Yes,
like
sir.
that. Out of 30, 5 contains the defective ones. We know. If 2 diodes are selected at random without replacement, what is the probability that at least one of these diodes is defective?
Yes,
Okay.
sir.
1
In those
minus
2,
20.
first case is
5
one
minus
of the
100,
diodes is
1 minute.
defective. Second
24 by
case is both
29.
the diodes are
Okay,
defective.
Sir, 270 by 870.
Sir,
27 by 8.
hello.
I am allowing to Kuntal, please. Yeah. Sorry. It is Ron.
Yes, sir.
Ron Tola.
Ajay Reddy, sir.
Ajay. Yeah. You just
Yes, sir.
proceed.
In the first case, we take one bulb as a defective one and the other as non-defective bulb. So for selecting one bulb from defective one, 5C1, and non-defective, 25C1. And in the denominator, we are selecting 2 balls from the 30 balls. So the in denominator, we get 30C2. In
But
the
sir, there will
second
be 2
case,
possibilities, sir, for that.
yes, sir. In the second case,
Either
we
we
take
get the
both the
first one
defective bulbs.
defective, or either we get the second one defective.
In the second case, we take both are defective. We have 2
49
bulbs
by 1.
defective, so we
Please
take
keep
5
silent.
C2.
No.
Someone have
talk.
to take the case. Sir,
Please.
one show the question, sir. One show the question.
I'm showing. Please, someone talking, then please keep silence. Otherwise, it is I am not getting actually. I'm showing the question and okay. So Shagnik, okay, I am just omitting. I am requesting to off your microphone by Ajay. Shagnik, what are you trying to say?
Sir, I got answer as 49 by 174.
49 by 174. No, that's not correct. Anyway,
No, sir.
so
54, 9
37
by
by
29.
87.
Okay.
There
Yes.
will be 2 possibilities.
Shubham.
First one will be
Sir, 9 by 29.
9 by 29, sir.
Exactly. Shubham, how did you get
Yes,
it?
sir. 9 by 29.
Shubham, can
Sir,
you
first we
explain?
will take the first
Sir,
we
1
will take
minus
the case of
0.69.
only one defective.
Wait. Please wait. Only Shubham is talking. Please silence others. Shubham,
Sir,
yes.
first we will take the case of one defective. So we will multiply 2 into 25 into 2 into 5 upon 29 into 30. So we will get 250 by 870. That is 25 by 87. And then we will take the case of 2 defective. That is 2 by 87. And we will add them 27 by 87. That corresponds to 9 by 29.
Sir, can I? Sir, can
Anyway,
I
Shubham,
explain?
you may silence.
Sir, can I explain?
Sure. Shomik,
sir.
no? Yeah. Shomik,
Yes.
explain properly so that your friends can get it. Show me.
Sir, there will be two possibilities. First one will be there will be only one defective, and the other possibilities there will be two defective. For the first possibility, the probability will be 5C1 by 30C1, and 5C1 into 25C1 by 30C2, and for the second possibility, that will be 5C2 by 30C2, and we have to add these two possibilities.
Sir, sir,
Can I say?
there's some. Sir, can I say?
Sir, can
Same,
I?
sir.
Can I try?
The answer will be 27 by 30,
Partho,
87.
yeah, yes, Partho, please. Partho.
So there is actually three cases. First of all, the first case is when we have taken one of the bulb is defective and another one of the bulb is also defective. The second case is when only one of the bulb is defective. Either the first bulb can be defective or the second bulb can be defective. So in that we get two parts of it. So it will be 2 into 5 by 30 into 25 by 30. That is when one of the
Sir,
bulbs are
we are,
defective. And when both the bulbs are
Sir,
defective,
can
it
I
is 5 by
explain?
30 into 4 by 29.
we
And
are
we'll sum all of it.
taking
Yeah,
both the
Sir,
bulbs
can I
at a
explain
time,
in
sir.
easy means
Hey,
easy
Ajay,
language,
can I
sir?
explain? Ajay,
Sir,
why are you
can I
talking?
say that?
Can I
Sir,
say
can I
explain in
say
easy?
that
Wait.
1 minus
So one
1
thing is that
minus
others also, I know, please wait. Others also wants to talk. Please, but someone talking, and if you parallelly, if you others are talking, then it is difficult to get
Sir, but
take it.
I have a doubt here.
Okay, let me clarify it is. Okay. So please don't talk. I am clarifying those who are feeling doubt about this problem. So here a box contains 3 diodes. Out of that 30 diodes, out of that 5 defective. That means similar previous. If 2 diodes are selected at random without replacement, what is the probability that at least one of these diode is defective? So let us do. So what is the probability that? So just previous one when we tried to solve this number 3. When at least generally we try to take 1 minus something. That means suppose what is the probability that if we draw 2 diodes randomly and without replacement, the all will be the non-defective. So first one non-defective is 25 by 30. This is the probability, and second one is the non-defective probability is 24 by 29. So in this case, this is the probability that non-defective. So what is the probability that at least one defective? It is 1 minus this. You can think like this way and simplify, we'll get this one. So what I want to conclude that whatever you are thinking, your thinking may not be wrong. So the probability for solving probability, it is different ways you can think. Whatever you are thinking, but final answer should be same. So you have tried to discuss about this your method. Maybe your method is correct. I am not getting, and some students gave it that is actually correct. So it's fine. You check it, your answer is coming or not, and parallelly you need to solve other problems so that your logic is actually correct or not. Okay. Yeah. Anyone? Yes, please.
Sir, there is written that 25 by 30 into 24 by 29. That is the probability of one non-defective, right, sir?
Exactly. None of these non-defective.
Okay, sir. Okay.
All of these, what I want to say, all of these non-defective. Yeah.
Okay.
And then we are taking just 1 minus this. That is the probably this is the easiest way, and this is the easiest way to think. Whatever you are thinking, probably that is correct. But you should care. So at least one defective, it is better none of these are defective. Then you take 1 minus that. That is the easiest way. Okay, let me shift from here to using Bayes theorem. Okay, let me give one problem. Just wait. Yeah, you read this number. Sorry, yeah, number 9. You try to solve this one. You try first. I'll verify with you with your answer. Then I'll just explain. Explanation is written here, but
So
not
we will
in
use
your.
Bayes theorem.
We will use Bayes theorem.
Yeah, you should use Bayes theorem. And try to use Bayes theorem and try to find the answer. I'm giving you 4 minutes only. Those who know, and those who don't know, please wait. I'm going to discuss about this. I hope you all received this assignment. You may see in this chatting box, that means in this MS
Which
Teams.
assignment?
Yeah, I have sent this PDF. You may collect. And I'm taking the attendance also parallelly. How many students here with us?
Sir, 33 by 68.
Wait, I'll see. Just wait.
3 by 68.
And 291 total attendance till now. Maybe some are.
33 by 68.
Sir, can you show the question once again?
I'm showing just after taking the attendance. Download attendance.
The 33 by 68. The 33 by 68.
Wait, I'll just check it.
Sir, 0.48. Yes, sir, 0.48.
Sir, 3 by 7 upon 3 by 7 plus 5 by 11.
0.485.
What is the answer?
Sir, 3 by 7 upon 3
0.485.
0.48.
33 by 68, sir.
Yes, sir. Yes, sir. Yes, sir.
Selecting on one is
Yes, sir.
1
This
by
is the
2.
answer.
Second one is 1
Yeah.
by 2.
So many students are getting. That is nice.
Yes, sir.
Yes, sir. Yes, sir. It is coming.
Okay, let me allow to discuss someone who has confident to discuss. That means you can give the idea to your friends. Anyone has fully confidence?
Yes, sir.
Nicely. Showmik. Okay, Showmik. Yes.
Sir, can you show the question?
Sure.
Sir, I also, sir.
No, Showmik. Okay. Showmik first. Don't talk in between Showmik. After finishing Showmik, I'll allow others. Please.
Yes, sir. For the Bayes theorem, on the upper side, it is said that we find white ball from the first box number 1. So on the upper side of the calculation, we have to take first the probability of getting the first box, that is half, into getting white ball from the first box, that will be 3 by 7, and on the downside it will be summation of all the probabilities, that will be half into 3 by 7 plus half into 5 by 11.
Yeah, actually, whatever you have said, I got it, but I don't know your friends get it not.
Sir,
Get
can I
it or
explain,
not.
sir?
Sir,
So, just 1 minute. If so, I'm not allowing others. I'm giving the explanation. The full solution is in my hand. You see this one. So this is the easiest way probably to discuss. Yeah. So here U1. Just I'm noting the U1 like this way. U1 is the ball is drawn from arm 1, and U2 the ball is drawn from arm 2. And W is the ball is white. Now our target is we want to find the probability of U1 given that white ball is drawn. So you see directly you can't find it. What is your information given in your hand? You can't find the probability that what is the probability that white ball is drawn from U1. Given that white ball drawn, what is the probability from U1? But using Bayes theorem, according to uh, conditional probability definition, we can find like this using the Bayes theorem. If you use the Bayes theorem goes to this one. You see probability of U1 given that white ball is this, we can just interchange it. That means probability of white ball chosen given that U1 is chosen. So after chosen U1 white ball, that means interchanging this U1 over W, we are taking W over U1. And similarly, we are taking the probability of U1, and below it is summation of all the cases. probability of U1 into white wall given in from U1 plus U2 probability of U2 white wall chosen given that U2 is chosen. So this what is the probability of U1? And you see, since it is two arms are there and both are similar, so the probability is that it is two cases, so probability is half. That means probability of choosing of arm 1 is half, and also probability of choosing arm 2 it is again half. So that's we have written here. Sorry. So that's we have written here. The probability of U1 equal to probability of U2 equal to half. And now, what is the probability that probability that white wall chosen such that U1 is that means already arm 1 is chosen. So now go back to the arm 1. You see, in arm 1 it is total seven balls. Out of these 7, it is 3 balls are white. So what is the probability that white ball will chosen? So it is 3 by 7. And arm 2, you see, it is 11 balls are there. 5 plus 6. So the total ball is 11, and out of this total 5 balls are white. So what is the probability that white ball are chosen from U2 arm 2? So it is actually 5 by 11. So that's it is written in here. Yeah, this one 3 by 7 and 5 by 11. And now whatever the you need, all are here given. So you put these values and you calculate, you will get this one. And some students are able to do. So I know that you have learned this is 10 plus 2. And so, and those who didn't learn this one, please go ahead and try to read any book. You will get it. And take your help, take help from your friends also. Okay, fine. Any questions or comments from this?
No, sir.
Okay, good.
No, it's fine.
Okay, thank you. No, similar question. I'm just changing almost similar question. I will try yourself. This number 10. Please do yourself. Try yourself. Just little bit generalization. Here 3 arms are there. Arm 1, arm 2, and arm 3. And first arm has these walls. Second arm has these walls, and third arm has these walls. Then similar question, you calculate and try to find the answer.
Sir, 2 by 5.
Sir, 2 by 5. Sir,
Sir,
2 by 5.
2 by 5.
Yes, 2 by 5. That is correct answer.
Yes.
Wait, please wait. Who gave the first answer?
2 by 5.
2 by 5. Who gave?
Same logic, sir.
Sir, 2
Sir,
by
Who said
5.
first?
Sir, 2 by
Can I-
5.
Yes, sir. Same
Tommy.
logic. 2 by 5.
Yes, sir.
Sir.
2 by 5.
Okay, I'll ask you. Wait. So your friends is trying. Your friends are trying. Please wait.
Sir, that will be same reason. Only change will be 1 by 3.
Yes, sir.
Yes, sir.
But
Good.
1 by 3 also get
The
eliminated
1 by
from
3
the
in
upper
the
side and
end
the
get
down side.
cancelled. So it doesn't matter we write 1 by 3 or not.
Yes, sir. And denominator also same 10. That will be also cancelled.
Sir, it is same question only. Only 3 answers.
Almost similar. Yeah, that's I have said. So
Yes,
I think no need to give more time to you for this one. So let me no need to discuss. I am discussing. Since it is similar, the answer is also written. If you discuss yourself, that's fine. But so same case we have taken here, Bayes theorem, and similarly we have taken U1, U2, U3, and since in this case is red wall, so we have taken R is red wall. Our target is we want to find that what is the probability of U1. Yeah, what is the probability that the arm 1 is chosen so that red wall is given that red wall is chosen.
Yes,
So
sir.
again we are using Bayes theorem. This is the Bayes theorem, whatever we have discussed previous. and you try to find this all the cases of the probability. So it is 3 arms and similar probability, so it is 1 by 3. And now, so you can find this type of probabilities. R, a red ball is chosen, so that given that U1 is chosen, so this is 6 by 10, you can easily find this. And therefore, the equation this, after putting these values, you are getting this 2 by 5. So you have given the answer 2 by 5. Is it? Yeah, that is correct. I hope you are getting. Is there any more discussion we need? I have briefly. No. Okay. So those who are feeling difficult, you need to raise your hand. That means you need to just unmute yourself and say me. Otherwise, I'll go ahead. Okay. So last one. You try to do this one. Last, number 11. You try this one. It is little bit different, but you need to do.
So the question, please.
Please to the question.
Oh, sorry.
Correct.
Sir, 28 by 69.
28 by 69. So if you do the fraction, what is the answer? That means 0 point something. Can you write like this from?
So 4 by 35 divided by 5 by 25 plus 4 by 35 plus 2 by 40.
Yes, sir. 100 will be divided.
What is
Yes,
the
sir, that
final
will be the answer.
So 0.
0.40.
0.405. 0.405.
0.40.
0.41.
0.40.
That will be 4 by 35 divided by 5 by 25 plus 4 by 35 by 2 by 40.
I don't know. In my hand, this is the answer. Maybe calculation mistake. Let me check.
Yes, sir, 0.405 has come, so it will be
This is
counted
coming,
as
sir.
0.41.
This is coming, sir. Right, sir. Right.
Sir,
Very right.
28 by 69.
Don't
This is
fight
right.
for the answer.
Sir, it is
16
coming
by
0.40579 something.
28 by 69.
Achha, 1 minute.
Sir, correct. 0.41. Correct, sir.
Okay, Rishabh, can you explain? Rishabh,
Yes, sir.
explain why the answer is this, or how do you solve this one?
So 7 by 20 multiplied by 1 by 25 divided by 1 by 80 plus 7 by 500 plus 4 by 500.
Sir, if I say that total bulbs are X, so then I have to find the 25% of X. So then I will get the how many bulbs will be manufactured. Then I have to minus the 5% defective is there, na, sir. So what I'm saying is 25%, 25 by 100 into total it is X. So X by 4 will be manufactured by the respective A, the company A. So 5% are defective. 5 by 100 into X by 4. So it will come X by 80. So like that we do for all three. Then selecting one company, that is 1 by 3rd, like applying the base theorem at last. So it is coming 0.41, sir. I got that idea. That's
Okay, that's fine. Okay, let me. That's your explanation is fine. Let me explain me also. This solution was. Yeah.
Sir?
Yes, please.
Sir, I was asking that only. The doubt means we will not be multiplying 1 by 3 here as we were doing in the other questions, because we are choosing B out of all the three.
But 1 by 3 will be cancelled from the upper and from
yes,
the
upper and lower side. 1 by 3 will be
that
cancelled.
will be no factor.
Oh, okay, 1 minute. I am giving the answer. Wait, here answer is in my hand. So here you see the again it is better if you write like this from the all the cases and then you find the probabilities and then write Bayes theorem and put these values, you will get the answer. So you see the A, we are talking that A is the bolt manufactured by machine A. Now we are considering B, the bolt is manufactured by the machine B, and C, bolt is the manufactured by C. Now you see the probability of A, it is given that 25% means 0.25. And similarly, probability of B is 0.35 and probability of C is 0.40. I hope up to this there is no confusion. That's fine. Now, our target is we want to find the probability of B by D. So, and now the probability of drawing the defective bolt manufactured by A is, that means probability of D given that A is chosen. So that is actually it is given also 0.05. That means 5% means 0.05. And similarly, this is D means defective. Okay, D means here actually defective ones, such that B is chosen defective ones. It is the probability is 0.04. And similarly, probability of defective, so that the C machine is constructing. So these are already, these all results are given. Now only we need to apply the Bayes theorem. And this Bayes theorem, our target, we want to find this probability of machine B so that we got the defective. For this one, we just using Bayes theorem, just reversing this one. It is B by D is given, so we need to put here D by B. And similar way we are doing. And then we are putting these values and you are getting this. Is there any confusion till now?
No, sir. No, sir.
Okay.
No, sir.
No.
Very good. Okay, thank you. So I hope you are getting the Bayes theorem. So so this is the this up to these two classes. Whatever we have discussed in the class, we already you know these things. Now next class we are going to discuss about the random variable. Are you familiar with that random variable?
No, sir.
Yes, random
No, sir.
variable. What?
So we'll start from here. Okay, next class, Monday. So
Sir, I have one doubt at the fourth question. Sir, I am not getting that third and fourth question. Once again, please explain the fourth question especially.
Sir, can we leave?
Yes, sir. Those who are doing.
just 1 minute. Just 1 minute. So what is your question? Please wait and wait another 1 minute. So the next class will start from random variables. Those who know, then fine. Those who don't know, that is also fine. I am going to discuss. And my assumption is that this one you don't know. So we'll try to discuss one by one what is that and using that. But the nice thing is that whatever we discuss these two classes, that is actually difficult part in probability. And what were remaining part, it is not difficult part. Only some formulas you need to remember and you need to solve some problems. Okay, so yeah, your class is finished. You may leave. Oh, I need to first recording.
Okay, sir. Thank you, sir.